Welcome to video 2 of the 6-part word problem quadratic stuff series. All right, second problem. The underside of a concrete underpass forms a parabolic arch. The arch is 30 meters wide at the bottom and is 10.8 meters high in the center. The blueprints for this underpass has indicated that a sidewalk needs to be built on either side of the underpass. The sidewalk should start 1.8 meters from the walls. What would be the headroom for this sidewalk, and do you consider it to be safe? First, I need to kind of draw a picture for this one because, again, it's kind of hard to visualize. So what I'm going to start with is a picture, and I have a parabolic underpass. And what we know about this underpass is that it is 30 meters wide at the base. What we also know about it is that it is 10.8 meters high at the center. So the distance from here down to the bottom is 10.8 meters. In order to try to come up with an equation for this, what we need to do is maybe put it onto an x and y axis. So I'm going to draw that in here. So if I was to draw this on grid paper, and I have my x and my y axis, what x would be is the distance from the left side. So if I'm kind of sitting right here at the center, I would be 15 meters away from the left side. If I'm over on this point here, way on the right side, then I'd be 30 meters away from the left side. What y is graphing here is the height at any given point. So the height of the arch. And so if I'm right at the top of my arch here, yes, I am going to be 15 meters to the right of the left side, and I'm going to be 10.8 meters up in the air. So we can kind of use these 2 points. This is going to help us come up with an equation. I'm going to come up with an equation in factored form. The reason I want to do that is that I have both of the zeros. I have one zero here at 0 and 0, and the other one at 30 and 0. As a reminder, zeros are just another word for x-intercept. I also have another key point. I have the vertex. This is going to happen halfway between 0 and 30, which would be 15, and at a height of 10.8. So if I start with this in factored form, I'll have y equals a times x minus r times x minus s. In this case, I don't know. I'm going to leave y as it is right now, and I don't know what a is. But my factors can come from my two x-intercepts. So here I would have x minus 0, which is just x. And then my other one will come from the 30. So I will have x minus 30. In order to put this into a graphing calculator or to kind of move forward, I need to figure out what my a value is. So I need to input a coordinate in for x and y. What's good about this problem is that we've been given the vertex, which is just a coordinate of x and y. So we're going to plug that in. We're going to use 15 as our x value and 10.8 as our y value. So we'll have 10.8 equals a. The x is 15, and we have 15 minus 30. Cleaning this up a bit, we have 10.8 equals a times 15 times negative 15. 15 times negative 15 will give us negative 225. So what we'll have here is negative 225 times a. To get a by itself, what I want to do is divide by 225 on both sides. So we'll have 10.8, and we're going to divide by negative 225. The left side will become negative 0.048. And the right side, those will cancel, and I'm left with just my a value. So in general, therefore, my full equation is going to be y equals negative 0.048, and my factors, which were x and x minus 30. Now we can actually put this into a calculator. I've actually already done that on the left side here. So when I go into y equals, here's my equation. We found our a value, and then we have our factors of x and x minus 30. Again, adjusting the window so that we can see it. Here, I've already kind of done that. What we can see is that on my x-axis, we were going from 0 to 30. So my minimum is 0, my maximum is 30. For the y scale, I was starting at 0, and I was reaching a maximum height of 10.8. So instead of using a decimal, I just went up to 11. When I hit graph, Here's what I see. And now this is kind of matching the picture that I've drawn. Now we can use this equation to solve for what we really want. What the question asked us is that there should be a sidewalk that should start at 1.8 meters from the walls. So if I was to add this into my picture, if I went 1.8 meters away from each wall, what we need to be doing is that we would start building a sidewalk here, and we would be doing the same thing on the other side. 1.8, and then I have a sidewalk. What they want to know is what would the headroom be on this sidewalk? So if someone was going to try to walk underneath here, how much headspace do they have? And is this space high enough? And is it safe? So what we need to do here is, well, I need to figure out what point am I inputting into my equation. If I'm 1.8 meters away from the left side and I was standing at this point here, what would the coordinate of that point be? Well, the coordinate would be 1.8, right? That would be my x value. So when I go up and figure, okay, well, what's the y value? That's what I don't know. We have 1.8, and then what is the y value? What we're really doing here is plugging in an x value. So let's plug this number into our equation. So we get, so when x is equal to 1.8, y will be equal to negative 0.048 times 1.8, I'm just replacing x, and then 1.8 minus 30. Let's clean this up. So we've got negative 0.048 multiplied by 1.8, and then we'll go 1.8 minus 30, and we're going to get negative 28.2. Let's multiply all of those together. What we should get here is 2.43648 meters. What we need to decide is if this is a safe headspace. For me personally, even though I've lived in Canada my entire life, I don't really understand meters when it comes to height. I think of my height as feet and inches. So what we could do is, if again, you may be in the same boat as me, maybe you know how tall that is. For me, I'm assuming that that's probably going to be a safe amount, but until I hear it in feet and inches, I probably wouldn't be sure. So how we can convert something between feet and inches is by using a conversion. So I know that 3.28 feet is equal to about 1 meter. The only reason I know that is because I am a math teacher and I do this my entire life. Obviously, I don't think most people know that off the top of their heads. But again, you could probably just Google this. Like, how do you convert between feet and meters? So 3.28 feet is equal to 1 meter. We want to know how many feet is 2.43648 meters. And we're going to cross multiply and divide. So we'll multiply the two numbers diagonally across from each other. What we get here is 7.99165, and that's now going to be in feet. So it's about 8 feet. Most people are not 8 feet tall. So again, that's probably going to be a safe height. So to answer the question that they've asked us, what would be the headroom of the sidewalk, and do you consider it to be safe? Well, the headroom is about 8 feet, or about 2.43648 meters, and yeah, that's probably going to be safe. Yes, it is safe. This concludes video number 2. Go ahead and watch video number 3.